Evaluating functions. When we evaluate functions, we simply look for the value of our function given a specified value of our variable. Example, in this case, we have our function f of x is equal to 3x minus 2. We are going to look for the value of this function when x is equal to negative 4. We can also state this as find f of negative 4. So that can also be written in this case. No? So to do that, we have to, again, substitute. No? We have to substitute the value of our variable in our equation. That is f of negative 4 is equal to 3 multiplied by the value of our x, which is equal to negative 4 minus 2. And that is equal to, we have f of negative 4 is equal to, what is 3 times negative 4? That is equal to negative 12 minus 2. Thus, our function f of x equals 3x minus 2 is equal to negative 12 minus 2 is negative 14 when x is equal to negative 4. That is, when x is negative 4, y is equal to negative 14. Let us have example number 2. Example number 2 is a quadratic function. Let us determine the value of this function when x is equal to negative 1. Again, this can also be written as what is f of negative 1. And that is equal to f of negative 1 is equal to, that is negative 1 squared minus 2 times negative 1 plus 4. Solving this, we have f of negative 1 is equal to, what is the square of negative 1? That is negative 1 times negative 1, that is equal to positive 1, minus 2 times negative 1 is negative 2 plus 4. Solving this, we have f of negative 1 again is equal to 1 minus negative 2. Keep, change, subtraction to addition. This is 1 plus, negative to positive. Then that is 1 plus 2. That is 3 plus 4 is equal to 7. Therefore, f of negative 1 is equal to 7. Or, the value of our function f of x equals x squared minus 2x plus 4 when x is equal to negative 1 is 7. When x is negative 1, y is 7. What did we do? We simply substitute, no? Replace our variable with the specified or given value of our, with its given or specified value. Next, example number 3. Example number 3 is a cubic function. We have f of x is equal to 2x cubed plus 5x minus 4 and determine its value when x is equal to negative 2. This is also the same as looking for f of negative 2. Okay. To do that, again, we substitute in our function f of negative 2 equals 2 times, okay, we have enclose this in a parenthesis, no? That is negative 2 squared, cube rather, negative 2 cube plus 5 times the value of x is again negative 2 minus 4. Solving this, we have equals, again, applying the Pythagoras rule, we do first what's in the exponent, no? 2 times negative 2 cube means negative 2 times negative 2 times negative 2, and that is equal to negative 8 plus 5 times negative 2 is equal to negative 10 minus 4. And solving this again, we have 2 times negative 8 is equal to negative 16 plus negative 10. Sorry. Again, 2 times negative 8 is negative 16 plus negative 10 minus 4. And negative 16 plus negative 10 is equal to negative 26 minus 4 is equal to negative 30. Thus, f of negative 2 is equal to negative 30. Again, the value of this function f of x equals 2x cubed plus 5x minus 4 when x is negative 2 is negative 30. When x is negative 2, y is negative 30. Example number 4. Example number 4 is a piecewise function. Evaluate the given piecewise function when x is equal to 3. Now, we are going to use the expression where our x satisfies, no? Or is located. That is, when x is 3, when x is less than or equal to negative 1, we will be using this function or expression 2x minus 3. And when x is greater than negative 1 but less than or equal to 5, we will be using 5 minus x squared. But if x is greater than 5, then we will be using this expression x plus 4. But the specified value is 3, positive 3. It falls between negative 1 and 5. Therefore, we will be evaluating this piecewise function using this expression 5 minus x squared. And that is f of 3 is equal to 5 minus, substituting already our x value, which is equal to 3 squared. And that is equals 5 minus 3 squared is 9. Thus, our piecewise function f of 3, 5 minus 9 is equal to negative 4. Thus, this piecewise function when x is equal to 3 is equal to negative 4. This is the evaluated value of function when x is 3. We used the expression where the domain or the x falls under, and that is 5 minus x squared. We always do this, no, in all piecewise functions that we are going to evaluate. Okay, don't forget that you look at the conditions here, no, where does your specified value fall under. Okay, and last example that we have is an absolute value function. Again, when you take the absolute, we always take the positive value. Okay, so to do this, again, this is also written as f of negative 2. Okay, and to do that, we f of negative 2 is equal to the absolute value of. Okay, the absolute value of, we have 4 multiplied by the value of x, which is negative 2, minus 1, minus 3. Next, we have that is equal to the absolute value of 4 times negative 2. We do multiplication first. 4 times negative 2 is negative 8, minus 1, and minus 3. And that is equal to, what is negative 8 minus 1? Negative 8 minus 1 is negative 9, minus 3. Okay, we will not do the subtraction for yet. No, we will not do the subtraction yet because we will first take the absolute value of negative 9. When we take the absolute value of number, we always take its positive equivalent. That is, negative 9, the absolute value of negative 9 is 9 minus 3. Thus, our absolute value function, f of x equals absolute value of 4x minus 1 minus 3 is equal to, when the specified value of x is negative 2, is equal to 6. 9 minus 3 is equal to 6. This absolute value function, absolute value of 4x minus 1 minus 3, is equal to 6 when x is equal to negative 2. When x is equal to negative 2, the value of our function is 6, or y is 6. That is evaluating functions. To evaluate functions, we simply, again, substitute no, the value of x in our variable, the specified value of our variable in our function, and we solve for its equivalent, okay? And we have our last example, wherein the given value or the specified value of our variable is also an expression. This is x plus 1. This can also be written as, or we can write this also as, look for f of x plus 1. See, this is also an expression. Now, when we evaluate functions, the cases are that we do not always have a number or a specified value, but it can also be as an expression, another expression. But we will be doing the same, no? We will still substitute and then simplify our function. Let's do this. That is, f of x plus 1 is equal to, as you can see, we have x squared minus 1. Let's put this in a parenthesis. We have x, sorry, it would be better if we square it, no? Okay, square, then put this in a parenthesis. We have x plus 1 squared, sorry, squared minus 1. Okay, and then we simplify this. We expand this, the square of x plus 1, and we have the square of a binomial. The square of a binomial, that is equal to square a binomial, we square first the first term. X times x is x squared. That is x squared, x squared. Then the middle term is twice the product of the terms. The two terms are x and 1. The product of the terms, again, twice the product of the terms. That is, x times 1 is x, and twice x is 2x. That is plus 2x. And to get our constant term, we get the square of our second term. That is, 1 squared is also 1. Thus, we have this, the square of x plus 1 is equal to x squared, square the first term, twice the product of the terms, that is x times 1. The terms are x and 1. X times 1 is x, twice it is 2x, and then square the second term or the last term. 1 squared is 1, then we have minus 1. Thus, our function, when the value of x is x plus 1, is equal to the quadratic function x squared plus 2x, because 1 minus 1 is 0. In this example, we have the specified value of x is an expression. And to do that, we simply do the same process, which is we substitute the expression, the specified expression in our function, and we simplify to get our function. That is evaluating functions.